Hi to all. Now we are going to discuss conversion of galvanometer into voltmeter, right? And how do you convert the galvanometer into voltmeter, that I am going to explain. What is a galvanometer? The galvanometer is a device that is used to measure the small currents. This is a galvanometer. Look here, capital G. This is a galvanometer. It can measure the small currents. Okay? And the maximum current measured by this galvanometer is Ig. That is the current measured by the galvanometer is Ig. The resistance of the galvanometer is capital G. Okay, the voltage, maximum voltage measured by the galvanometer is Vg. Voltage across the galvanometer, V suffix G. Voltage across the galvanometer. This is a galvanometer. Galvanometer. Okay. And what is G in this? G is the resistance of galvanometer. Okay, resistance of galvanometer. And what is Ig? Ig is the maximum current. Maximum current. Okay, through the galvanometer. Maximum current through the galvanometer for full scale deflection. For full scale deflection. Full scale means complete bending of the pointer. Okay, it shows the last reading. At that moment, maximum current. How much current we have to send in order to show the maximum voltage? Maximum current through the galvanometer for full scale deflection. Full scale deflection. That means this is the maximum current that can allow to the galvanometer. If you will send more than that, it can damage. And what is Vg? Vg is the, okay, that is old reading when it is as galvanometer. That is maximum voltage. Maximum voltage measured by galvanometer. Measured by galvanometer. Galvanometer maximum how much voltage it can measure. This is old reading. Why it is old reading? Before converting the galvanometer into voltmeter, we are taking the reading. That's why it is old reading. And now we are going to convert this galvanometer into voltmeter. What we have to do it here? Galvanometer measures the small voltages, but voltmeter can measure the large voltages. For that we have to connect high resistance in series. Right? We have to connect high resistance in series. This is high resistance. We are connecting this high resistance in series. Then when you will connect the high resistance in series, then that galvanometer automatically convert into voltmeter. Right, it can measure the current Ig, okay, and the same current passes here Ig. And now this is the voltmeter. Okay, what is this? This is the voltmeter. Now it is said to be voltmeter. Right, it is said to be voltmeter. Voltage across the galvanometer is V suffix G. Voltage across the resistance is V suffix R. V suffix R. The total voltage measured by it is V. Okay? And this is now voltmeter. Okay? Simply we are connecting the galvanometer into voltmeter. Simply you can tell how we will convert the galvanometer into voltmeter. Okay? Just by connecting high resistance in series to it. What is capital R? Capital R is the series resistance. Resistance connected in series to the galvanometer. Okay, resistance connected in series. Connected in series to galvanometer. Right? Okay, then some more terms are there here. I will write every term. What are the terms that we are using in this? What is VR? V suffix R. Voltage across high resistance, right? Okay, what is V? V is important. V is the new reading, okay, or the new voltage, new maximum voltage measured by galvanometer after converting into voltmeter. Okay, after converting into voltmeter, right? After converting into voltmeter, we have converted this into voltmeter. Then what is the reading measured by it? That is V. V is the new reading. The old reading is Vg. That is the maximum old voltage measured by the galvanometer. The new voltage is new maximum voltage measured by the galvanometer after converting into voltmeter is V. Here, for example, how you are converting that I will write here. Galvanometer converted into voltmeter by connecting high resistance in series to it. Okay, this is the galvanometer. For that, if you will connect high resistance in series, then automatically it will convert into voltmeter. It was very simple. Okay, and these are some points regarding converting the galvanometer into voltmeter. Then how much high resistance we have to connect? I am going to derive the formula for the resistance that should be connected to the galvanometer in order to convert that into voltmeter. Then from figure we write one thing. What we write from figure? V is equal total voltage V here, that is Vg plus Vr we write. V suffix G plus V suffix R. V is equal total voltage. Vg we write as current into resistance. Voltage across galvanometer, current into resistance, plus Vr we write as current into resistance. Same current Ig, the resistance is R. I want to know the formula for R. We can common the Ig at here. I suffix G, G plus R. We take this Ig to left side, then V by Ig is equal, we will get as G plus R. From this, I want the R formula. Then how you will get the R formula from that? It was very simple. That is, we take G to left side, then we will get the R. R is equal, we will get as V by Ig minus, we write as Z. This is the formula for the high resistance that should be connected in series in order to convert the galvanometer into voltmeter. This is equation 1. And here V is the new reading, Ig is the maximum current through the galvanometer for full scale deflection, minus G is the resistance of galvanometer. If range of galvanometer increased by n times, okay, if range of galvanometer is increased by n times, before that I want to write this in terms of Vg, okay, but we know one thing, but we know voltage across galvanometer is current into resistance, Ig into G. We write from here Ig is equal, we write as Vg by G. This we substitute here. Then R is equal, we will get as V by Vg by G minus G. This we write as R is equal to V by Vg into G minus G. Here the G is common, we will get as V by Vg minus 1. This is the formula for R. Now for example, if the range of galvanometer increased by n times, if the range of galvanometer increased by n times, that means the new reading, new voltage V is equal to, we write as n in times of old voltage Vg. This we substitute in above equation. What you will get? That is R is equal to we will get as G into, instead of V write NVG, we write NVG by Vg minus 1. Vg will cancel. Then we will get final formula is R is equal to G into N minus 1. This is the formula for the high resistance. Okay. This is equation 5. Now what is the effective resistance of this ammeter? Voltmeter. Effective resistance of voltmeter. After converting the galvanometer into voltmeter, what is its effective resistance? Effective resistance of voltmeter. Right? G and R are in parallel, then effective resistance G and R are in series. Is it right? That's well. Then we will get the effective resistance as G plus R. Just in series we have to add them. Right? This is equation 6. And now this is about conversion of galvanometer into voltmeter. You take the screenshot and note it. Okay? And now I will tell one problem based on this and I will close. Okay, this is the simple question that I am going to explain. A galvanometer coil has the resistance of 12 ohm. The galvanometer, this is a galvanometer. When you connect this high resistance in series, you will convert this galvanometer into voltmeter by connecting high resistance in series. The maximum current of the galvanometer is Ig, I suffix G. Let us see here what they gave in the question. Resistance of the galvanometer is 12 ohm. And the galvanometer shows the full scale deflection for a current. Galvanometer shows the full scale deflection current 3 milliampere. You convert this into amperes. Okay. How will you convert the galvanometer into voltmeter? That should be measured 18 volts. Right? How you will convert? In order to convert the galvanometer into voltmeter, we have to connect a high resistance in series. That high resistance formula is what? R is equal to V by Ig minus G. Right? And now in this we have to substitute all values. R is equal to V. V is what? 18 we want to measure. Ig is 3 into 10 to the power of minus 3. Minus G is 12 ohm. Now we have to simplify it. It was very simple. R is equal to 18 into, this goes to numerator, 10 to the power of 3 by 3 minus G is 12. 3 6 are. Then we will get as R is equal to 6000 minus 12. Then what we will get the answer? Okay. 10 minus 2, 8. This is 9, 9. 9 minus 1, 8, 9, 5. Okay, this much resistance we have to connect in series in order to convert the galvanometer into voltmeter. Right? Galvanometer is converted into voltmeter. Converted into voltmeter into voltmeter. How? Into voltmeter by connecting 5988 ohm resistance in series to it. Right? This is our solution. Okay, it was very simple, and these two are important topics. Okay, and take the screenshot and note it. Thank you for watching my lectures.